The ICEVI, the Nippon Foundation Mathematics Package for Teachers video series, Abacus as a Mathematical Tool. Title of the video, Square Root of 6-digit number involving 5 zeros as lower digits. Example, 200,000. Let us use this example, 200,000 with 5 zeros at the end, and demonstrate that it is not a perfect square. That means it does not give a round square root. Let us set the number 200,000 by leaving 3 columns in the right extreme of the abacus. That is, first 0 in the 4th column and the second 0 next to it, third next to it on the left, 4th next to it on the left, 5th next to it on the left, and finally 2 to the left of the 0. Now, for the purpose of calculation, we can consider the groups of this number as 20, 0, 0 and 0, 0. Take the first group 20 and consider the perfect squares there. 4, 9 and 16 are the perfect squares in 20. Therefore, let us take 16, which is the highest perfect square, and take the square root of 4. Set the 4 to the immediate left of the number 2 and subtract 16 from 20 and you will get 4. Now you are left with 4, 0, 0, 0, 0. That is 40,000. In the next stage, double the number 4 and set 8 in the extreme left of the abacus. Now consider 8 and 40. Ask how many 8s in 40? You get 5. As it is giving a quotient without a remainder, it is safe to reduce 1 and consider 4 as the assumed quotient. In case of small numbers, there is no need to go for an assumed quotient. And in the case of higher numbers, it is always safe to go for an assumed quotient. Set the number 4 to the right of the first digit of the square root 4 and to the right of the number 8, which is set in the left extreme of the abacus. Now multiply 4 with 84. That is 4 multiplied with 8, that is 32. That should be subtracted from 40 and that will give you the remainder as 8, and with the addition of the 0 you will get the remainder as 80. Now 4 is multiplied with 4, which is 16. That should be subtracted from 80 and you get the remainder as 64. Now you have completed the 2 sets and now we are going for the third set. In the second set of operation, the remainder is 64. And let us add the remaining 2 zeros. Now you are left with 6400. Look at the square root now. It is 44. Then it should be doubled and therefore the 84 should be removed and you set 88 there. Now consider 88 and 6,400. Look at the first 2 digits of the dividend and the first digit of the divisor. Ask how many 8s in 64 by saying 8, reduce 1 for safety and set the 7 to the right of the square root 44 and also to the right of the number 88. Now 7 should be multiplied with 887 and that should be subtracted from 6400. You can treat 7 multiplied by 887 as a separate multiplication problem and you will get the value as 6209. The 6209 should be subtracted from 6400 and you will get the remainder as 191. The remainder now is 191. Now you have to go for your decimal part of the square root. Add 10 to the remainder 191 and make it as 1910. From here on, you can simply follow the regular division procedures in getting the decimal part of the square root. For getting the divisor, you can double the square root 447, which is 894. As there are 2 8s in 19, the first 2 digits of the dividend, consider the first decimal number as 2. That is, you will get the square root at this stage as 447.2. Now multiply 2 with 894, that is 1788. That should be subtracted from 1910 and we get the remainder as 122. Add 0 to this number 122, that makes it 1220 to get the second decimal digit of the square root. When we are going to the second decimal of the square root, you can round off the divisor and get approximate values. Now 894 is closer to 900. So therefore you can consider the divisor as 900 and ask how many 900s in 1220 by saying 1, place the value to the right side of the square root, which is making it as 447.21. Now subtract 894, that is 1 multiplied by 894 from 1220 and you will get the remainder as 326. Now we are going for the third decimal digit of the square root. Therefore, add 0 to the 326, which makes it 3260. Now look at the divisor, which is 894. There are 3 900s in 3260 and therefore use 3 as the third decimal digit of the square root. Now 3 is multiplied with 894, which is 2682, and when you subtract that from 3260, you will get the remaining value as 578. Now we have to go for correction with the third decimal digit. Let us look at the remainder 578, which is higher than the midpoint 447 of the divisor 894, and therefore the decimal part of the square root may be rounded off to 447.214. Hope this elaborate explanation helps in finding out the square root and also their decimal parts. Let us do some more problems dealing with zeros at the end of the number.